Alright, in this demonstration we're going to review how to solve for the height of a projectile. Projectile, which is just a fancy word for something flying through the air. In this case, in our demonstration, it is a ball, and in this sample problem, pretty simple, a ball is thrown upwards with an initial velocity of 22 meters per second. How long is the ball in the air, and how high does the ball go? So we have a situation like this, where we have a ball thrown upward at a velocity of 20 meters per second, and it's going to travel up and then it's going to travel back down. Now in reality it's going to go straight up and then straight down, but I drew it this way so it's a little easier to see. So 20 meters per second up and then back down. Now we have gravity, which has an acceleration of 9.8 meters per second squared. It's bringing the ball back down to Earth, so the ball is going to go slower and slower and slower as it travels up until at the peak here at the apex it has a velocity of 0, where it hovers in the air for a brief second, and that's going to come back down to Earth. And we need to solve for how long is the ball in the air, this value t, and then how high, or the maximum height, this value h. Now we're going to use two equations here. Now the first equation we're going to be using is to solve for velocity. So it's v equals v naught, or v initial, or v original. I was taught to pronounce it v naught, so that's how I do it. So we have v equals v naught plus the acceleration times time. Then our second equation, x, or distance, x equals x naught plus v naught t, so we have velocity times time, plus 1/2 times our acceleration times our time squared. And if you were to check all the units, for this first one we have velocity equals velocity plus velocity, and then this one we have distance equals distance plus distance plus distance, the way the units all cancel each other out. So first we'll solve for the amount of time it takes the ball to reach its maximum height, this height h over here, right here. And we're going to use equation A, this first one, using velocity. It's going to find the time it takes to reach h. So velocity equals v naught plus at. If we subtract v naught from both sides, we get v minus v naught equals at, and then we divide both sides of the equation by a, and we have v minus v naught divided by a equals t. So we have t by itself. We've isolated our variable, so now all we have to do is plug in our values and we're set. So because my acceleration is the acceleration of gravity over here, gravity's pulling it down, so instead of a, I can just plug in a lowercase g. Equation's still the same. So at the peak height, the velocity is 0, as already mentioned. So we're going to substitute 0 into our equation for v, and 22 for the initial velocity. It tells us up here the initial velocity is 22 meters per second. So we have t equals 0 minus 22, so that's v minus v naught, right there, 0 minus 22, divided by negative 9.8, which are acceleration of gravity. T equals negative 22 divided by negative 9.8. Negative divided by a negative is a positive, and we get 2.24 seconds. Now this value, 2.24 seconds, that is the time it takes to go up to the top here, but they want the total time, so the time up and the time down together. So since it takes 2.24 seconds for the ball to reach the maximum height, it takes that exact same amount of time to come back down. So all I have to do is double it, and we have our total time of 4.48 seconds. So that takes care of the first part. How long was the ball in the air? 4.48 seconds. So now, how high does it go? So for that, we're going to use the second equation. So because the acceleration is due to gravity again, and it's pulling the ball downwards, I can rewrite it so I can plug in a g, and since it's negative, I can put a negative sign there instead of a plus sign. So I have x equals x naught plus v naught t minus 1/2 gt squared. Now we already know the initial velocity is 22 meters per second, and we're assuming the initial height is 0. Now in reality, you wouldn't be throwing the ball directly from the ground, but they don't tell us explicitly what it is, so we're going to plug in 0 to make our lives a little easier. And the time to reach the maximum height was the 2.24 seconds, the halfway up, not the full 4.48. So if we plug those values into our equation, we have our distance x equals our initial distance, which was 0. our velocity times our time, 22 times 2.24, minus 1/2 times our acceleration times our time squared, and we do the math and we get x equals 49.3 minus 24.6, which is 24.7 meters high. So for our picture here, it took 2.24 seconds to go up, an additional 2.24 to come down, so 4.48 seconds total trip time, and a maximum height of 24.7 meters.